Welcome to Lesson 3.5, Fractions. Today we're going to talk about identifying the parts of a fraction, identifying different types of fractions, and how to place fractions on a number line. So first and foremost, we need to go over our vocabulary. A fraction represents a part of a whole. So when you're talking about a fraction, that means you're not talking about a whole group, or in terms of pizza, you're not talking about a whole pizza. You're talking about what's left of the pizza or slices of the pizza. So the fraction 4/5 means you have 4 parts out of the 5 that you need to make a whole. The numerator. The numerator is the number in the fraction that represents the part. This is the number that's on top of the fraction bar. So in the fraction 4/5, you have the numerator of 4, which tells you there are 4 parts out of the 5 that you need to make one whole. Then the denominator is the number that represents how many parts you need to make a whole, and that number will be below the fraction bar. So the denominator in this case would be 5, and it tells you you need that many pieces, or in this case 5, to make one whole group. So with this fraction, I have 4 out of 5. If I get one more part, I would make one whole group. A mixed number. So think of the word mixed. It means you have a variety of pieces. You have different pieces put together. In a mixed number, you have a whole number, so one piece, with a fraction, your second piece. So it's a mix of a whole number and a fraction. This means there is or are whole groups, so there's one or more full or whole groups and a part of a group. So with that 4/5, if we put a 4 in front of it, let's say, that means we have 4 whole groups, and then we also have 4 out of 5 of a partial group. Okay, again, look at how this whole group, this whole number, is written almost as big as the entire fraction is. Your whole number should always be bigger or as big as your fraction is. That indicates that it is a whole group. Okay, an improper fraction is when the numerator is larger than the denominator. More specifically, when the number of parts is larger than the amount needed for a whole group. So an improper fraction is what you'll see when we're just talking about the number of pieces that we have. So we're not talking about how many whole groups do we have, we're talking about how many pieces do we have total. So 5/4, for example. We have 5 pieces, and yes, we only need 4 to make a whole group, but I want to know how many pieces I have total. So I have 5 pieces out of the 4 that I need to make a whole group. So this implies that there is a whole group, but we don't have a whole number written in front of it. All right, so let's talk about what these pieces represent. So we've talked about how the numerator tells us how many we have. So in this case, we have 4. And the denominator tells us how many we need to make a whole group. So in this case, I need 9 to make a whole group. So what this fraction means is that I have 4, so I've shaded in 4, out of the 9 pieces total that I need to make a whole group. Or if you're talking about pizza, I have 4 slices out of the 9 that I need to make a whole pizza. But now, what if we were to add a whole number to this and make it into a mixed number? Because we understand what 4/9 means. It means we have 4 out of 9. Notice your denominator, we say it with that THS. It sounds like a decimal. That's supposed to be that way because of the fact that we're talking about parts. So whenever you're talking about something in math that has a part, you'll see that THS at the end. So we have 4/9 because we don't have a whole group, we have a partial group. With decimals, we talk about tenths, hundredths, thousandths. So those words, those THS words, imply to us that we're working with parts of a whole and not a whole group. So it implies to us that we're either working with a fraction or a decimal if you don't have something visual in front of you to tell you which one it is. Typically, if you're talking about ninths, fourths, and stuff like that, typically you're talking about a fraction, even though all fractions can be changed to decimals. Typically when you're talking about ninths, fourths, anything that's not a power of 10, you're talking about a fraction because decimals only have powers of 10 for place values. Okay, so now if we throw a whole number in front of this, say a 2, what does that mean? What does that change to? Well, this 2 tells me how many whole groups we have, or how many groups of the denominator we have. So this 2 means that I have 2 groups of 9. So let's take a look at what that would be in picture form. So here, and actually I can turn this to make it a little bit easier for you to see. Here, this is telling me that I have 2 pizzas that were cut into 9 slices each, and I have those 2 full pizzas. So I have 2 groups of 9, and then I also have a group of 4 out of 9. So I have 2 full groups of 9, and then I have 4/9 left over. So if I were to look at this as in how many slices of pizza do I have? Well, here I have 18 slices, plus 4 more would be 22. So I have 22 slices, and I'm putting 9 in each pizza. So visually, this is what this picture means. It means I have 2 full pizzas, and then I have 4/9 of a pizza, or 4 slices out of the 9 of another pizza. So let's look at these problems. Let's explain what each of these means. So I'm going to go ahead and type so it goes a little faster and is a little easier to read. So my whole number tells me again how many of each group or how many of the denominator I have. So my whole number tells me I have 3 groups of 5. And then my fraction tells me that I have 2 out of 5. So in this case, I could even say this is equal to having 15 because I have 3 groups of 5. And then this is still 2 out of 5. So then here, we'll take a look at 9 and 1/7. So the whole number tells me I have 9 groups of 7, because the whole number means I have 9 groups of the denominator. So I have 9 groups with 7 pieces each, which means I have 63, well, I'll say parts. And then my fraction tells me that I have 1 out of 7. So it tells me that I could make 9 full groups of 7 and I had 1 left over. Okay. We can really get used to what these fractions are telling us and what they mean. Working with them and converting them is going to become a lot easier. So my whole number tells me I have 10 groups of 6. So that means I have 60 parts total. And my fraction tells me that I have 5 out of 6. So I was able to make 10 groups of 6, and then I had 5 pieces left over out of the 6 that I would need to make a whole group. All right, so my improper fraction, instead of telling me how many whole groups I have, it just tells me how many pieces I have. So yes, 9/4 tells me that I would have a full group, but I don't want to write it with how many whole groups I have. I want to know just how many pieces I have. So I'd leave it as an improper fraction. So the 9 tells me I have 9 pieces, and the 4 just tells me how many I need to make a whole group. So it's kind of like taking a bag of marbles and dumping it on the floor and saying everybody needs to take 4. And I have 9 marbles. So I have 9 marbles that have to go into groups of 4. Okay, so what would each of these mean? So this would mean I have 42 pieces and 5 go in each group. This one would mean I have 31 pieces and 7 go in each group. Or I could even say I have 31 pieces and 7 make a whole group, because that ties in our whole number. So I have 42 pieces, and 5 make a whole group. So here what you'll see is that yes, I obviously have enough to make a couple of whole groups, but I don't want to just yet. I just want to know how many pieces I have. So I have 15 pieces, and 6 go in each group. Or I have 15 pieces, and 6 make a whole group. So this would tell me how to create my mixed number, which we will talk about a little bit further down the road. Right? So we really want to make sure we understand what the parts of a fraction mean, because I promise you it'll make things easier when we talk about adding, multiplying, dividing, all that stuff, converting from mixed to improper. When we do all those things, knowing and understanding what the fractions mean will definitely help out. All right, so if we're identifying numbers on the number line, one, if they give you a number line and give you the numbers, you have to know that what each line represents. So in this case, if the line is 6 3/7, then, and this one is 6 6/7, then if we have one more, it's not that this is worth 1 whole, this is worth 1/7. So from here to here is worth 1/7, not 1 whole. So then what we would find here is that this number would be 6 4/7 because we're adding on one more seventh. And here we would have 6 5/7. Okay, and then now we get to 6 7/7, of course, would be the next one. But we know that 7/7 actually means 1 whole. So it's not that it's 7/7 because this is 6 and then another whole group. So this would actually be 7. So that's why the next number goes to 7 1/7. Okay, and then you can try these next two and see if you get them correct. And then when you come back, we can take a look at those answers. So you should have gotten that you had 7 2/7 for your next answer, for the next line, and then the line after that would be 7 3/7. So when you're placing numbers on a number line, you have to really look at where the numbers are and what they're being split into, because we're really used to a number line that just goes 1, 2, 3, 4. Now we're going in between the 1 and the 2 and the 3. So here, let's actually change this up a little bit. Instead of having this be a 0, let's have this be a 4 and this be a 5. So from 4 to 5 is 1 whole. So from here to here is 1 whole. But that's not what we're looking at. We're looking at all the little things in between. So what we have to figure out is, what was it broken into? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. So I counted the spaces in between. Notice I didn't count the lines. The reason being, when we tell students just to count the lines, they typically forget to count the last one. So we like to go 1, 2, 3, 4, 5, 6, 7 and say that these are worth 7s. But they're not, because if you do that, you're skipping this whole last group right here. You're basically taking this one out of the equation. And we can't. We have to keep that one in. So we actually have 8. You're looking at how many groups you made between the 4 and the 5. And I made 8 little groups. So I took the 1 whole, I took this whole thing here, and I split it into 8 smaller parts. So each one of these then, so if this is 4, and I split this into smaller parts, and I split it into 8 smaller parts, then this one here would be 4 1/8. because I still have 4 whole groups, but now I didn't add another whole group, I just added an eighth of a whole group. And I know that it's worth 8 because I looked at how much I split that whole group into. So it's like I took this whole pizza, even though it's not a circle, it's like I took this whole pizza and split it into 8 slices. So this is, I have 4 whole pizzas and another 1 out of 8 slices. Or the next one would be that I have 4 whole pizzas and then 2 out of the 8 slices. And then the next one would be 3 out of 8 slices, so 4 3/8. And then my next one would be 4 4/8, which we know is 4 1/2. So you could say that, but we're just going to stick with eighths right now just to get used to it. Then I have 4 5/8. And then I have 4 6/8. Now notice this actually gets pretty easy as we're going through. I'm sure you're going, okay, yeah, I get this. This makes total sense. The hardest part is determining what your denominator is, what those small pieces are. Because like I said, people like to count the lines and then they say 7. Well, here we would have gotten to 7/7. And I know that 7/7 equals 1 whole, but I wouldn't have been to another whole yet. I would have had this whole small group here. So count the spaces in between, and that will tell you how many parts you broke that whole group into. Okay, so then here the 5 wouldn't just be 5, it could be written as 4 and 7/7, which we know is equal to 5. Okay, so if I gave you any number on the number line, you should be able to look at it and tell me what number it is. And now it's not just going to be a whole number, it's actually going to be what we call a rational number. It's just going to be a number with a fraction. It could be just a fraction or it could be a mixed number. It all depends on where it is. If it's between 0 and 1, then it's just going to be a fraction because 0 tells me I don't have any whole groups. Once we get past 1 though, then we're starting to talk about whole groups and mixed numbers. Okay, so now you're going to take a shot at this and you are going to identify the numbers on the number line. So I want you to tell me, so these are going to tell me what each of them means. So what does 16/5 mean? And on here, you're going to tell me what are the missing numbers. And then on this number line, you are going to tell me A and B, what are they equal to? And then I want you to try and identify or place the rest of the numbers as well. But A and B for sure, you need to be able to tell me what they represent. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.